This is a tour of a duodenum specimen, and this particular specimen has been fixed very well, stained with H&E, and it is cut very thin, so you can see more detail of the cells and the nuclei. So let's take a look at it. There are several annotations that we have created here to guide your study of this, so I'm just going to run through them. And showing M indicates the mucosa, S the submucosa, and E the muscularis externa. Now in the duodenum, to confirm that's the duodenum, you're going to have to find villi, and you're going to have to find mucus glands in the submucosa. And that's what this next annotation shows. Here are several villi indicated. You see they're finger shaped, like if I outline one here like this and I zoom in on it, you can see that this is the tip here bordering the lumen, and this is the base, and then these short collections of cells here that don't always show a connection to the base of the villus are intestinal glands. There's a Paneth cell right there, another one here. But if we zoom out now, these are mucus glands in the submucosa. So the combination of villi and the submucosal mucus glands confirms that it is duodenum. There isn't any other part of the GI tract that has that combination. The esophagus may have submucosal mucus glands, but the epithelium, there are no villi, and the epithelium is stratified squamous non-keratinized epithelium. So let's take a look. If we look at the detail of the villi and the mucus glands and the Paneth cells, you can use this annotation to see that detail. I'm going to zoom in right here because you can see, and I've got another annotation of that, but you see this thin red border here. That represents the tremendous concentration of microvilli on the surface. So this increases the surface area for absorption and transfer of materials across from the lumen into the lamina propria. Now here's another area where you can see a goblet cell, and you can see the striated border that is red and staining intensely because of the high density of microvilli. This is a goblet cell. Ordinarily they look empty, and you're going to see one of those in the colon specimen. We're going to look at it in a minute. But in this particular specimen, they're retaining the material due to the good fixation, and so the mucus is staining very lightly eosinophilic. But you can see the shape of the cell and the nucleus gives it away as a goblet cell. I can just show you a couple more. There's a goblet cell there. This is the red blood cells in the capillary. Now these granules could be either eosinophils or mast cells. You can't be sure unless you can see the nucleus, and I can't make out the nucleus. But if you look around in the lamina propria, you can see fibroblast nuclei, and you can see smooth muscle cells, because there is some movement, and I think in the lecture you will see the role of smooth muscle cells in kind of foreshortening the villi to stir the contents of the interface of the lumen and the striated border in the epithelial cells. So there's maybe one more annotation, a detail of a villus. So try to point that out. Now when you see these cells that have no stain around in their cytoplasm, there's one there, and I think I could spot maybe a couple more. Let me just see here. I'm going to pause this, and here's a good example one. These are the enterochromaffin cells, and they secrete catecholamine, serotonin into the lamina propria and have some role in the process of digestion. So this is a good specimen to see some of the detailed morphology and nuclear shape in the specimen of a duodenum.